Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, November 18th. Looking at significant wave heights for the North Pacific Ocean, we see remnants of a gale still producing seas in the 16-17 foot range, aim east, but not of any particular importance at this moment in time. But the good news is, much better things, theoretically, are coming. As usual, we'll start this week's tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they do form, help direct their track. We're looking for a trough, that is a dip in the jet, just like that right there. That, in the upper atmosphere, helps create a counterclockwise circulation, and that also manifests itself down on the surface as a counterclockwise circulation, and that is the hallmark of low pressure. And of course, low pressure generates winds, winds generate seas, seas as they radiate away from the fetch area turn into swell, and when those swells hit your beach, that makes surf. All right, so right now, the jet stream is not particularly coherent. There's a bit of energy, 130 knot winds trying to build over Japan, but you see as soon as the jet gets out off of Japan, it splits a little bit, not heavily, but a bit. And then the northern branch, that's the most influential branch, makes it up to the North Dateline region, falls southeast, and starts developing a trough, but is only, there's 140 knot winds feeding the trough, but only over a very small area. That would very much limit the potential for a gale development in this area, maybe low pressure at best. And then the northern branch splits yet again massively, and see, here's the southern branch. It actually rejoins the southern branch, pushing into Baja, part of it, the other part pushing way up into Alaska. Between the split jet stream flows, you get high pressure, and of course, that's what makes for no wind if you're near the core of the high, and if there's a fire, then that drives smoke down the coast. Exactly what has been happening for a week along the Northern California, Central California coast, making even things in the water not very comfortable, but certainly pale in comparison to the poor folks up in paradise. All right, let's move on. As we move into Monday, much of the same pattern continues. There's the trough. That's the only real area of interest. The winds do start building to 140 knots over and pushing off of Japan. This trough continues to dig down. Now, it's not a massive trough by any stretch of the imagination, but any kind of a trough that will push this big high-pressure system off to the east is good news, because this high has just been locked over California all of fall so far. Pretty typical of La Nina, just kind of making for a very, very dry pattern. As we get into Wednesday, the trough continues. New wind energy feeds into it at, about 110 knots. Nothing too dramatic, to 120. Look at this. And the southern branch of the jet stream merges with the northern branch. That's a perfect setup for rain or precipitation into California by Wednesday. And continuing into Thursday, it looks like, also notice wind energy supposedly building dramatically over Japan to 170 knots. And up to 190 knots as we get into Thursday night. This is the first real push of the jet stream that we've seen forecast. Now, it's not happened. It's a forecast, 102 hours out. But still, the first real push forecast this entire fall. So it finally looks like maybe fall will begin over Thanksgiving. We continue on, another trough building, being supported by 190, almost 200 knot winds pushing up to the dateline. There you go, building trough. That starts right in this area right here, not super clean. Also notice the original trough moving into California. That'll probably shut off the rain production. Split jet stream building, more high pressure possible. But look at that, actually a semi-decent energetic trough forecast for the dateline on Saturday. We'll believe it when it happens, but at this point in time, we'll take anything. We're desperate. Jet stream continues split over California into Sunday. Trough looking pretty good, pushing into the western Gulf. More energy building back off Japan to 170 knots. And there we are at 180 hours out. A very healthy jet stream flow pushing off Japan with a trough. Another trough building in the Gulf of Alaska, split jet stream flow over California, probably a drying pattern there, but that might not be such a bad thing. All right, let's go take a look down at the surface. Here we are, surface level pressure, surface level winds. Of course, high pressure, 1028 millibar, high pressure, locked over the date line. Just nothing good particularly happening. A little bit of low pressure, trying to develop 996 millibars in the Gulf of Alaska. That's not even, that's hardly low pressure. And 112 or 1012 millibar low off of Point Conception. That's not really anything either. As we get into Monday, yes, 30-knot winds start developing in association. We'll call it a gradient. Weak low pressure in the Gulf, high pressure at 1032 millibars in the dateline region. The tightening of isobars between the two differing pressure systems creates wind, and that might generate some wind swell, we'll say, but nothing more. We continue looking out, and then we see low pressure trying to organize Tuesday off of California. Also another low off the Kuril Islands. Nothing too dramatic initially. Then we see perhaps a better organized low way off the northern Kurils, so far away and not particularly organized. Weak low pressure off California on Wednesday. That moves inland. Then we go, oh, here we go, little tiny area, 50-knot winds. We're kind of ignoring the tropical system down here. Yes, it might happen, but these models, when you're looking even 84 hours out, we tend to not believe it until it actually forms, but we'll keep our eye on it just the same. All right, so we're into Thursday. Look at this. So we'll go back just a little bit in relation to rain. So low pressure, this looks like a front moving right along here. Watch this front sweep into the Pacific Northwest down to San Francisco on Friday. Here comes low pressure building off Japan, another low pressure in the Gulf. 45-knot winds, that looks like 55-knot winds minimum. This whole general area is what they call a complex gale. Multiple gale centers, all pushing off to the east. Look, it's broad area, 50-knot winds as we get into 18Z on Friday with fetch, lots of fetch aimed at us. Building up to 55 knots. You can see it just under the tag there, some purple. As we get into Friday night, high pressure off of California. Maybe that's a good thing. There you go. There's your 55-knot winds pushing off to the east on Saturday. Also notice the tropical system making a move, recurving to the northeast. This all looks very good. We're into Sunday. The gale fading off of, or actually fading as it moves into the Gulf. High pressure holding off California. Let's see what happens as we're at 180 hours. We can't get into Monday yet. Still, very positive looking pattern, finally. Let's go take a look at the wave models. We're going back to Friday. Friday a few days ago, little low developed off of Kamchatka, building 28-foot seas, sweeping off to the east. This is no big deal. This will probably make for small, we're talking 3 feet at 16 seconds for Hawaii or something like that. But what the remnants of this low are pushing into the Gulf of Alaska as of 18Z Sunday. And now we're at current time. We see these remnant seas slowly easing into the Gulf, getting a little bit amplified. We're talking 18-foot seas. No big deal. But the point being, this could make for some wind swell pushing into California. But more so, it's the low pressure, weak as it may be, still giving potential for precipitation into California. Now, another gale develops off of Kamchatka on Thursday. Remember, we see a whole flurry of activity starting about that time period. Now, watch this little bit of energy pushing off of Japan as we get into Thursday night, Friday, and instantly we have now those 56-foot seas are supposedly associated with the tropical system, so ignore that. But we're into 40-plus foot seas in one small gale just west of the dateline come Friday, another gale with a tiny area of 40-foot seas, and another gale behind that with 33-foot seas. Finally, it looks like the North Pacific could wake up. And we move deeper into this. You see that little tiny speck of yellow? That's up here at the high end of the scale. 52-foot seas and more. You can read it for yourself. We don't need to detail it all out. But you see clearly a bunch of energy pushing over the dateline into the Gulf of Alaska. Swell working its way into Hawaii, bound for the U.S. West Coast. Bound for the U.S. West Coast at 180 hours out. Here is the composite of all significant wave heights for the entire 1 week period, all on one chart. You can see the main system here with, what is that, 52-foot seas in one little area. The other gale in the Gulf with up to 40-foot seas. Yeah, just barely 40 foot. And that all that energy pushing off to the east. The target right here is the catcher's mitt. This whole area, theoretically, could get sprayed with real swell, not even counting what's supposedly going to happen with a tropical system. So, the good news is we have something good to report. Finally, after months of nothing but negativity, something good to report. And let's go take a look at precipitation. We're not so much interested in Hawaii, but this area here, drought is in effect. Any drop of precipitation would be a good thing. If one is to believe the models, and we've been watching this for a couple of days now, and the models have been consistently holding solid with precipitation moving into Northern California on Wednesday morning, down into Central California by late morning, with snow in the higher elevations of the Sierra by Wednesday night, building pretty solid into Wednesday night and Thursday morning, then trickling out. But then another system pushes into the northwest. I mean, yeah, Whistler in that area has gotten some snow. Over Jackson Hole, they've gotten some. But this area, pretty dry. That looks like that's finally going to come to an end, too. Thursday night, yet more and pretty solid precipitation in Northern California, working its way south into Friday night and then petering out a bit, and yet maybe more for the Pacific Northwest, but then you see high pressure building in. We know the jet's going to split there, so that'll be the end of that bit of moisture, at least for the time being. A quick look at snowfall amounts, and you can see this yourself. All you have to do is, let's see, there we go, so, snow, right there, you click there. But anyway, this for Squaw Valley, you see supposedly a foot, maybe, what was that, maybe 14 or 16 inches worth of snow, mainly all centered right around in this area. So what's that, November 22nd, 23rd. Snow levels, important. These are new charts that we built. So here's the bottom of the resort, base. Here's the peak of the resort. Here's the temperature profile from 14,000 feet down to ground level. If you see red, that means liquid precipitation. If you see the gray, that means like sleet, sort of a mix. If you see white, for sure snow. Temperature's 32 degrees or less. And the blue, we'll call it amplified snow, 28 degrees or less. So you see the freezing level working its way down to the peak and almost down to the base, well, definitely down to the base of the resort as we get into that same 22nd, 23rd time period, and then slowly creeping back up. So finally, the first snow of the season as we get into Thanksgiving. Oh, and wind too. Same deal. Wind, mid-mountain gusts, and mid-mountain wind, the green and the blue. So right there you can see gusts. Yeah, pretty windy, maybe 40 knots up high. And at the peak, up at the peak, it's the red and the orange. You can see gusts up to maybe 60 knots. So pretty windy, probably not skiable, certainly not enough snow to ski, but any bit of it is good news. We'll take it. All right, let's go take a look long term. What's going on with the MJO and the El Nino Southern Oscillation? And I think it should be pretty obvious what's going on with the MJO. As usual, we'll start looking at winds on the equatorial Pacific. East Pacific here, West Pacific here. There's New Guinea. This would be like Ecuador off the chart over here somewhere. This is the equator right down the middle. The arrows are what we're looking at. Winds from the east over the entire equatorial region till you get to just past the date line. And then we see actual west winds blowing pretty decently over in the far West Pacific. That is the Kelvin wave generation area from 170 west off to 135 east, right in this area, 5 degrees north and south of the equator. When you have west winds in that area, we typically say, or west anomalies even, then that is a good sign of a potential active phase of the MJO. If it persists long enough and moves its way east, that could be El Nino. And yeah, so anyway, and anomalies. Differences from normal for this time of year. In the East Pacific, yeah, the arrows are kind of just noodling nowhere. Nothing going on. Pretty much normal. Even though it looks like they're blowing pretty good, that's just normal for this time of year. But in the West Pacific and the Kelvin wave generation area, Winds from the west a bit, so that is another sign of the active phase of the MJO. Of course, the active phase of the MJO in winter months helps impart energy to the jet stream, and if you have an active and energetic jet stream, then you get storm formation, and then you get surf, and that certainly seems to be what's going on right now. What's the wind been doing for the past 5 days? Okay, well, here's South America, here's Mexico, there's New Guinea, the Philippines, Australia, Kelvin wave generation area. Oh, the equator is right there. Kelvin wave generation area, this little box right in here. The arrows from the west suggest, of course, westerly anomalies. These are wind 850 millibar wind anomalies. That's up about 4,700 feet in the air, but still a good proxy for what's going on down at the surface. So this was on November 11th, and you can sort of see it for yourself right in this area. Westerly anomalies, not super huge, not strong, but there are westerly anomalies. So that suggests that the inactive phase of the MJO, which we've been in for a while and which has been tearing the jet stream apart, is finally gone. Perhaps the active phase is building, and that's what is imparting energy to the jet stream. We saw the jet stream models. We saw the jet's just going to get stronger and stronger as we move forward. Here's that same data, but this is winds, zonal wind anomalies over the entire planet. All we care about is the area around the dateline. Dateline's right here in the Kelvin wave generation area between these two tick marks. So you go down, you can see here in October, the reds, oranges, that is westerly anomaly. So this is probably an active phase of the MJO into like the Halloween time frame. Then inactive phase, and now you can see somewhere around November, the active phase is trying to get going, and theoretically is blowing pretty good right in the heart of the Kelvin wave generation area right now, and forecast to hold for the next week. Now, not as strong, but build in coverage. Notice there's a bunch of easterly anomalies. Remember, the Kelvin wave generation area cuts off right here. So the active phase is only like halfway into the Kelvin wave generation area and is not supposed to really fill in until about the 23rd of November. So it only looks like things are going to get better from here. Let's go out 2 weeks. So we don't have wind anomaly charts, but we have outgoing long-wave radiation charts. They suggest areas where you get more or less sunlight reflectivity off the ocean surface. Negative numbers are less sunlight reflectivity. That could be interpreted as low pressure, which would mean more cloudiness, which would mean the active phase of the MJO. And per the statistic model, the active phase of the MJO, there's today, there's 5 days from now, 10 days, 2 weeks out, active phase, holding steady. This would be great if this happens. That would be continued support or energy transport into the jet stream and continued support for gale development. Now, the GEFS model, a little bit different, suggesting, yeah, basically the same thing, but then the active phase moving east quicker and the inactive phase moving from the Indian Ocean towards the maritime continent and over into the West Pacific 2 weeks out. So the real question is, which one of these two models is right, or is it some combination of the two? Too early to know. You're looking at a model 2 weeks out. That is not something I'd believe too much. Phase diagram charts. So another way of looking at the active phase of the MJO and its relative strength. So this circle, assume you're looking down on the North Pole, and the MJO, whether it's active or inactive, moves from west to east, from the Indian Ocean over the maritime continent, across the West Pacific, under the United States, across the Atlantic, across North Africa, back to the Indian Ocean. Heavy dot is where the active phase of the MJO is, or basically right over the maritime continent, okay? If the dot is outside of the circle, it's considered to be, kind of a minimal strength. If it's way out in here, then it's considered to be very strong. So a very weak active phase of the MJO over the maritime continent. The green dots, or the green line here, suggests the path, moving weakly to the West Pacific and into the East Pacific and then into the Atlantic 2 weeks out. Per this, the ECMF model. The GEFS model now showing that no, the active phase of the MJO is to get actually pretty solidly strong over the West Pacific. And if you could count these dots, and it's kind of hard to, we'll just sort of 1, 2, 3, 4, 5, 6, 7, 8, 9 days out, 10, 11, 12, 13. So for the next 2 weeks, for the most part, strong active phase, and then fading out of the West Pacific and moving out of the Kelvin wave generation area. Let's go out 40 days. All right, so the greens are areas favorable for precipitation. The yellows not favorable. There's South America. There's New Guinea. There's your equator right there. This presumably is the active phase of the MJO, moving from west to east into Central America and gone by December 10th. So that basically correlates with what we saw in the other charts. And then the inactive phase comes along behind, getting established in the West Pacific at the end of November, and then moving into Central America by Christmas. But at that time, starting again about, say, mid-December, another active phase of the MJO moving into the West Pacific. So from a swell perspective, yeah, the next 2 weeks probably look pretty good. And then the next window of opportunity would be, let's say, mid-December on through Christmas into New Year's. Not so bad. So let's go a little further. This is 850 millibar wind anomalies again. Again, the whole planet on one chart. Kelvin wave generation area between these two tick marks. There's the date line right there. You see reds and that sort of stuff. That's westerly anomalies, but this is past history. Strong active phase of the MJO back in September. Here we are today. Here is our westerly anomalies, and actually they're associated with ER, equatorial Rossby wave, and the building active phase of the MJO intersecting, creating west anomalies. There's those eastern anomalies encroaching on the Kelvin wave generation area, but that's supposed to be out and somewhere by, a week from now, so that'd be November 24th, down into about December 1st. Things looking pretty good, but then December 1st, we see a lot of easterly anomalies. One can assume that's the inactive phase of the MJO. Now, the point being here, if El Nino was really in play, you also see this here. This is the low-pass filter from this version of the model, suggesting it all but evaporates about 2 weeks out. And this would be your hope for El Nino, the thought being that El Nino probably wouldn't develop, and it just sort of peters out as we get into when it should be actually peaking. So that's a little bit of a downside, but maybe not, actually. We really don't want El Nino now. There's not been enough heat buildup in the ocean yet to get a legit El Nino, so why even try to tease us with a halfway El Nino, only then to go through another 2 or 3 years of La Nina? So basically, a normal pattern we think is setting up. All right, the same model, CFS, 850 millibar wind anomalies, but this one's in reverse direction, so past performance is here. Here's where we are today. Kelvin wave generation area between these two tick marks going up, so right between there and there. A little bit of yellows, that's westerly anomalies. There's our little easterly anomaly thing. As we get into December, this is saying not easterly anomalies, not westerly anomalies, just dead neutral. And then as we get by December 4th, it's westerly anomalies, continuing nonstop and actually getting pretty strong as we get into the January timeframe. Now, this model has, this version or this depiction of the model has been a little bit overhyping things. I'm not necessarily certain that it's going to develop as strong as this, but some degree of westerly anomalies are forecast. Let's overlay the MJO. There we go. Here's our active phase of the MJO into about December 4th. So all that's coherent with what we've seen somewhere elsewhere. There's our inactive phase of the MJO, just like we thought into, I thought it was about the 15th of December, but this says maybe to the 20th. But either way, westerly anomalies prevailing. That's good news. That still supports the jet stream, even though the inactive phase is in control. And then once you get to December 20th, the floodgates open. Active phase of the MJO continues the whole way into February. Westerly anomalies in control. If there was ever a big fat target right here for swell development, that would be it right there. All this is we're just getting warmed up. This is basically we're starting to get into fall. The fall pattern has finally kicked in. It's, assuming we get some of the storms that are forecast on Friday. If that happens, then I'd say we're into the fall pattern. All right. Low pass filter. Now see, this model says the low pass biased towards low pressure, holding, it's in control on the date line and is expected to continue the whole way into February. and holding strength. So a little bit of a disparity between the two models. It's hard to say what's driving one. I mean, that other CFS model, just the way it's done, seems to always be on the negative side. This one seems to always be on the positive side. Reality is probably somewhere down the middle, but generally a favorable forecast expected as we get deeper into winter. All right, so much for the MJO. What's going on in the ocean? We need to understand that to understand if there's any prayer for El Nino. All right, West Pacific here, East Pacific here. This data from the TAO buoy array, these X's are these are the anchor lines on the TAO buoys strung the whole way across the equator from East Pacific to West Pacific. The X's are the sensors on the anchor lines, and they are used to help give us some indicator what temperatures are doing in the ocean. During El Nino, warm water sloshes off to the east. So we have warm water. It's held steady. This is 30 degrees Celsius, steady at 180. It's been there for months. No change. The 28-degree isotherm line at 157. It's been toggling between 160 and 153, something like that. So no big change. The 24-degree isotherm at 102 west. Last week, I think it was pushing onshore, or maybe it was the week before that, into Ecuador. It's backtracked a little bit. Let's go take a look at anomalies. That'll explain what's going on. Differences from normal for this time of year. Now we see very warm temperatures, 5 degrees above normal, pushing into Ecuador right now. We see 3 degrees working their way back to, where's the date line? Right there. Okay, so to the date line, and then less west of there. This warm water was actually caused by a big Kelvin wave, created westerly anomalies blowing from west to east in the far West Pacific, created warm water, pushed warm water to depth. It made it the whole way across traveled the whole way across the Pacific down about 150 meters. This is a Kelvin wave. This is Kelvin wave number 2. It is moving onshore over Ecuador. The concern here is there's nothing really behind it. And El Nino typically peaks in the Christmas time frame. Well, there's nothing queued up, and it takes 3 months to get from here to here. Nothing queued up behind. When you say El Nino's coming, I'd say probably not if this is all you're getting in terms of warm water. I mean, that's a fair amount of warm water, but it takes multiple Kelvin waves over multiple time period. I mean, starting in like February, and we just haven't had it. Not a particularly, yes, this is not La Nina. You'd see cool water here, but it's not really El Nino either. Another version of that, the same data using a different model. Still see, what is this? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 5-degree anomalies. That's quite warm. That's 5 degrees Celsius. Off of Ecuador, actually south of California, on the equator. And warm water, again, off to, well, there's somewhere in there's the end of this Kelvin wave. You also see cooler anomalies off of New Guinea right now. Hopefully that's just the upwelling phase of the Kelvin wave cycle. So we'll see. Still, lots of warm water. I mean, it'll take from here 2.5 months for all this warm water to erupt at the ocean surface over the Galapagos in that area. And then another couple of months to then get caught by the trades and pushed into the main El Nino monitoring region from 120 west to 170 west, 5 degrees north and south of the equator right in here. So you see warm water on the ocean surface is the surface right here, but it's originating from down below. Let's put all this in some historical perspective. Recent history, December 2017. Cool water. This is East Pacific here, West Pacific here. Cool water in the East Pacific. That is the hallmark of La Nina. You see a little bit of warm water working off to the east. That was a weak Kelvin wave that faded out in January. First Kelvin wave number 1 in February. Made it across the Pacific, but kind of faltered and barely limped into Ecuador in the June time frame. Upwelling phase of the Kelvin wave cycle. Things cool off a little bit. Here's our much stronger Kelvin wave number 2 right here. Still working its way off to the east. the end of it is here, and we suspect this is the upwelling phase of the Kelvin wave cycle, just like that one there. The question is there more behind it? And by more, we're talking next year, into next summer, into next fall, or will this all just sort of slowly go to sleep and we just fall into a neutral pattern? Sea level anomalies, another way to get a sort of a guess on what's happening temperature-wise subsurface. Here's the equator, here's the dateline, there's South America, Mexico, there's New Guinea. These yellows and oranges are positive anomalies. That is, this is JSON-2 satellite data. Strip out all the wave heights, strip out the tides, strip out the wind waves. You see a bulge on the ocean surface from, there's New Guinea, north of New Guinea, actually coming from somewhere back in the maritime continent, easing off into the Pacific and building, though these two pockets here kind of are tearing at some of, sort of indicative of weakening height anomalies, 5 centimeter anomalies, one little pocket of 10 degrees. This has definitely come down, especially in this region in the past week or so, but branching north and south a little bit. This is certainly not a La Nina pattern, but it looks like El Nino, but let's dig a little deeper. All right, sea surface temperature anomalies. This is the way you really get a sense of what's going on in the ocean, whether the ocean's trying to push you towards an El Nino. Clear signal here, these reds above normal temperatures from Ecuador, Peru, Central America, over the Galapagos, out the whole way out to the dateline. The main El Nino monitoring region from 120 west, 5 degrees north and south of the equator, out to 170. Clearly, it looks like temperatures are above normal. And we see this, so the Nino 1.2 region is like right around in here. That measures or gives you an index of whether temperatures off of Peru are above normal. In a normal El Nino, that's a pretty solid one. You'd expect to see kind of a triangle going out like that and up like that. Instead, we see this thin little stream right on the dateline, nothing more, kind of a very limited in nature and not super hot either. Yeah, there's pockets, but there's nothing really cooking and nothing expansive and nothing suggesting a significant oceanic response to the 2 Kelvin waves that we've had so far. The 7-day trend, are the temperatures getting warmer or cooler in the past week? Well, the blues are cooler, and this is the main area we're looking at is on the equator. If you really want to measure it, it's 5 degrees north and south out here, 120 to 170. But all that warmness in this area would originate over here. We see cool, 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 cool. So, this is actually getting cooler, not warmer. So that's suggesting that even the modest, or we'll call it the fragile El Nino footprint that we have right now, if anything, is cooling. And then just getting out of the weeds and looking at the picture, yeah, we have a warm regime. These are anomalies, sea surface temperature anomalies, and not a giant footprint. Main El Nino monitoring region, right over in here. Yeah, it's warmer. It's a lot better than it being cooler, but it's not significantly warmer, and we're coming out of La Nina. The suspicion is the atmosphere is still biased towards La Nina. This has to go on for months and months before the atmosphere really so this is the ocean, remember, and the ocean drives the atmosphere. And so, yeah, the ocean's warming, but it hasn't been warming very much for very long, and the atmosphere is trying to pick up on it, but just hasn't got there yet. It senses something's going on. But you have to change the entire circulation of the atmosphere over the entire planet. And that's when El Nino starts doing its thing in the atmosphere, and that reinforces what's going on in the ocean. And typically that sort of coupling, if you're going to have a good El Nino, would start in July or August. And here we are in November. They're not coupled. And so you get this sort of very tepid, fragile response. Sea surface temperatures in the Nino 1.2 region. This is the area right up along Peru, the Galapagos, Ecuador. Today, 0.8 of a degree above normal and building slightly. But you can sort of see, just look at the pattern since August. Yeah, if you were to draw a line through this, I'd say I'd probably put it a trend line somewhere. I'd probably do it like this. And it would only be maybe 0.4 of a degree above normal. This isn't even the official El Nino monitoring region. So this is the area that feeds the official El Nino monitoring region. So kind of a tepid response. Here is the 3.4 region, the official monitoring region. Today's value, 0.492. And if you kind of look at this, yeah, we had a good little spike there, but that only lasted, what, a week and a half. Otherwise, if you were to put a trend line through this, yeah, it was dead neutral. We've been, we'll call it 0.5 degree above normal, maybe 0.6 of a degree above normal since the beginning of October. So, you know, well, about almost 2 months. So, yeah, we're warmer than normal. Officially, El Nino is 0.5 degree above normal for 5 months. We're only not even 2 months into that 5-month time period. So you can see the atmosphere hasn't really had a chance to respond yet, you know, and by the time it does, it'll be spring and it'll be all over. All right, so we've talked about the MJO, we've talked about subsurface sea temperature anomalies, we talked about surface temperature anomalies, what's going on in the atmosphere above the ocean. Well, we look at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When the index is negative for, you know, a couple of weeks, that's an indication of the active phase of the MJO. Today's value, minus 18.01, and it was minus 25 yesterday. But you kind of look, that's 4 days of negative numbers, doesn't really make a trend. You kind of look back all this month, and if anything, I'd say the numbers are biased positive, not negative. So, yes, it looks like we're heading towards the active phase of the MJO, but even that isn't certain yet. 30-day average SOI, well, we were positive for sure. Back November 8th, we were at 4.28. You get the idea. And now we're down at minus 0.76, so we're heading in the right direction. 90-day average, this is for monitoring El Nino development. Well, minus 2.29 is basically dead neutral. If you were down at minus 15 or something, then we'd say, hey, maybe there's El Nino going on. And you go back and you look, where were we? Minus 4.67 back around Halloween time. We've actually lost ground, and we're down to minus 2.29 today. Here's the 30-day average charted out. So back in January 2016, when we were in El Nino, and you can actually see this, active phase of the MJO, inactive phase, active, inactive. The average was down somewhere around 15, minus 15, minus 20. That's El Nino. Then we went into La Nina in July of 2016, January 2017. Not a particularly strong La Nina, you know, but still positive average, you know, 5 or 7 or something like that. And then here is our quote-unquote building El Nino, which is, if I just trend line through that, minus 3, something like that. You know, here's our current active phase of the MJO developing, but we're not down here. We're nowhere near El Nino territory. We're basically in neutral territory. The ocean and the atmosphere do not appear to be coupled. And then another measure of coupling of the ocean and the atmosphere. Instead of looking at the difference in pressure between the area north of Darwin, Australia, and Tahiti, we look at rainfall differences. Because if you have warm water out in here and the atmosphere senses it, at some point you're going to get more evaporation, and more evaporation is going to lead to more precipitation and more cloud cover. And so this index is the amount of rainfall in this area. Is it more or less than normal? Today's index, minus 0.03. So effectively dead neutral in here. No less rainfall than normal. I mean, we're at minus 0.3, I think, or 0.25 last week, something like that. And we had been hanging there for a couple of weeks. I mean, we haven't even really been positive once this year in this area. But for a couple of weeks back, yeah, I think it was October, something like that. Anyway, so dead neutral right now. Let's look at one other thing. And you can see that on this chart. Outgoing long-wave radiation anomalies. That is precipitation differences for normal. And this is the anomaly. Here's what's actually going on, but here's the anomaly. Differences from normal for this time of year. Yeah, we have more precipitation. The blues, more cloud cover, less sunlight reflectivity, more supposed rainfall over in here. But this is the big area that we're interested in, is right in here. And it looks, yeah, maybe a little bit right there. But I mean, in this main area here, the 120 west to 170 west in there, pretty dry, dead neutral, nothing suggesting El Nino. If you had El Nino, you should be having good rain over in this area. We're not seeing it. And then finally, this model, no different than any of the others, CFS model, Nino 3.4 sea surface temperature anomaly forecast. Well, the model is saying, let's say right there is November 15th, and it's saying temperatures are 0.85. It's not there. We know that to be a fact. It's down about 0.5. And the model says temperatures are maybe going to rise another little bit, drop off a little bit, maybe rise a little bit more, but toggle right around, let's say 1 degree above normal, give or take, 0.9 to 0.1, 0.1. If temperatures are actually down about here right now, we'd say we're going to hover between half a degree to 0.6 of a degree above normal the whole way through winter. So the bad news about that is that's not El Nino. But the good news is, yeah, but it certainly isn't La Nina where we've been for 2 years. So the thought is once we finally we're going through a transition right now, right? La Nina, we're trying to get rid of La Nina in the atmosphere. We're trying to get rid of the inherent La Nina pattern that the jet stream has been in for 2 years now. Hence the blob, they call it, the big high-pressure ridge off of California. That's slowly breaking down, but we're at least, we're 6 weeks behind normal in terms of seasonal change. That's, again, part of the La Nina thing, and that will slowly break down, and eventually our seasons will get more in sync, at least on the West Coast. We're not going to see these El Nino temperatures. We will probably eke out at best a bare minimal El Nino, but the hope is that, well, maybe we'll just sort of hover here with slightly above normal temperatures, not for this year, but continue into next year, and maybe the year after that. And you know what? That slow, steady, warm buildup actually does more for producing surf than having one big splurge where El Nino goes crazy for a year and then you fall back into 2 years of La Nina. Would much rather have this slow, warm, not even El Nino kind of trend that just goes on for now to next year and the year after that. And that just feeds the jet stream a little bit at a time and builds a multi-year pattern of building storms, precipitation into California, et cetera, and that in turn maybe could be used to help us understand more what's going to go on with the PDO, and we're not going to get into that because we're running late. But the thought is, right now the PDO is kind of just dead neutral. It's not showing any clear signs of moving into the warm phase, or that it's in the warm phase, but this might help get us there. So we'll just have to see. So to put a bow on it, right now, things are looking, at least forecast-wise, much better. Storms on the forecast, precipitation on the forecast, snow on the forecast relative to California. El Nino, yeah, it's forecast, don't believe it, but a general warm trend, that's good. It's not La Nina. So more and more we're getting the sense we're moving into a much better regime long-term for snow and surf development over the next couple of years. So that's a good thing. And even better, there is a real storm on the chart for the next coming up in about 5 days, and maybe the opportunity for real surf. So that's good news. All right, that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.